Okay, let's get started, class. Okay, what you learned yesterday, you guys, was actually, like I said, it was pretty straightforward. When you don't have a teacher, it might be a little bit confusing. Trust me, you will be prepared to do that stuff on the test. We're actually going to do a little bit of it today, and I think you'll understand exactly what it is. But today what we do is much more important than what happened yesterday, and it can be more challenging. Now, although it's maybe a little bit more challenging, went very, very well second hour. I expect it to go well now. The key word today is composition function. And we're going to study the composition of functions. This is something entirely new to you, and you're going to have to learn some new terminology. The terminology that you're going to see is this. F of g might also be written as f of g of x, might also be written as f of g of x. And that's how I'm going to define it. This little circle in the middle there means composition. So f composed of g of x is actually defined as, the way we're going to think of it, is f of g of x. So whenever you see that, you could rewrite it to look like that if it makes more sense to you. And here's what that means. If we have an x value within the domain and we plug it into g, something happens to it. G is a rule. Do you know what we get out when we plug x into g? G of x. So out comes g of x. Once we arrive at g of x, do you know where we plug it into then? We plug it into f. And what you get out then is f of g of x. So it results in plugging in twice. This is not a situation where you multiply. A lot of people read this, they said this is f times g. No. That's why they use this dot in the middle, this circle, f composed. And so we'll try an example here. I think you'll understand it. This says f of g of 0. Before I worry about the f at all, I'm going to worry about the g of 0. If you want to find g of 0, what are you going to do? Right, so g of 0 is equal to 0 squared minus 2 times 0, which is, oh, I'm sorry, you guys have a plus sign. 0. So in other words, f of g of 0 is actually asking me to evaluate f of 0. So now I take that 0 and I plug it into 2x minus 3. I get 2 times 0 minus 3 is negative 3. Now, it's different if we switch it around. If we try g of f of 0, that's different. What is f of 0? Negative 3. F of 0 is going to be 2 times 0 minus 3, which is negative 3. So I can replace that f of 0 with negative 3. So really I'm trying to evaluate g of negative 3. And that's equal to negative 3 quantity squared plus 2 times negative 3, or 9 plus negative 6, which is positive 3. That's the result. So you plug x in, you get an output for g, and then you plug that output of g in for x, and you get a new output. Do you think you could try a couple? Again, for C, if you see f of g of negative 2, what that really means is f of g of negative 2. Why don't you try C, D, E, and F? Try those 4 on your own. I'll pause this. Just C, D, E, and F. So let's just check really quick. You guys should come up with, what, negative 3? And then D should have been 35. E was negative 5. And what's F? 15. Is there one of those that somebody was really confused on that you want to see? 35. We can do that. Yeah, it's correct. I worked it out last hour. So what we have is we need to find f of -2 first. If we plug in -2, 2 times -2 is -4 minus 3 is -7. So really you're evaluating g of -7, which is -7 quantity squared minus 2 times -7. Or I'm sorry, plus. You guys got plus there. So that's 49 minus 14, which is 35. Okay? So I understand we might make an algebraic mistake, or I should say an arithmetic mistake. But with that said, do you understand the process? Okay, let's try ones that are a little bit different. F of g of x. So what this is saying is I actually want a rule. Forget about actually finding a value. I want a rule. And so I'm going to use f of x is equal to 2x minus 3. I'm going to use g of x is equal to x squared plus 2x. So what I need to do with g of x, what is g of x? It's x squared plus 2x. What I really need is f of, note that g of x is x squared plus 2x. So I've got f of x squared plus 2x. So that's what I'm really being asked to do. What do I do with that? Where? Good. So what I have is I take that x squared plus 2x and I plug it in for the x for the function f. And I get 2 times x squared plus 2x minus 3. Yeah? Which is 2x squared plus 4x minus 3, done and done. So that's the rule of that function once it's composed together. Yep. In fact, if you were to leave it like this on the test, I'd probably give you full credit. I'm not so concerned that you can simplify stuff algebraically. That's what last year was for the most part. I want to see that you can write it in this notation. You should know that these two answers are the same in the end. G of f of x, what do I do now? That looks hard. What do I do? So I have g of what? 2x minus 3. So that means what I need to do is I need to take 2x minus 3, that quantity squared, plus 2 times 2x minus 3, right? How do I square 2x minus 3? FOIL it. First outside, inside last. So I got to FOIL 2x minus 3. 4x squared, very good. I would get a negative 6x and a negative 6x, which is a negative 12x. I would get negative 3 times negative 3 is 9er. 2 times 2x is 4x. And 2 times negative 3 is negative 6. Beautiful. So this is not acceptable on the test. This is not acceptable because you have to combine like terms, right? Got to do that. Four x squared minus 8x plus 3. So that's acceptable. So there you go. There you got it. Yeah. If I said on the test I want it written in polynomial form, then the end results for both would be in polynomial form. I got cake today from Kelly Nelson. She brought me cake last hour. I ate it and it was good. And I didn't feel bad for anybody else who didn't get cake. Christine, you got cake? From who? What? Raise your hand if you had cake last hour. This is ridiculous. She told me I was special. Forget her. I'm done. All right. Let's do one more. Let's cross off J. I don't want to do it. Let's do I. We've got f of x. Can you do that? Sure can. This would be f of 2x minus 3. So you can plug the 2x minus 3 in for x, and you would get 2 times 2x minus 3 minus 3. Or 4x minus 6 minus 3, which is 4x minus 9. Any questions on that? Going once, twice, thrice, flip it over. I erased my drawing. I got to draw it again. I'm going to pause. Okay, yes, Gens is no good. We'll pick up now. We'll forget about the boy-girl conversation. We'll stop there. So this is kind of from yesterday. If you look, I've got a, oh no, that's right. Let's go f plus g of 2. If you want to do that, all you have to do is f of 2 plus g of 2. I got a graph here. What's f of 2? 5. What's g of 2? What's that? No. I'm using the graph. So I got f of x here. So f of 2 is 5. And g of 2 is negative 1. 4. So that's graphical addition, you guys. We'll sketch it after we're done here if you want. G minus f of 0. So now I find, what's g of 0? Yeah. So g of 0 would be at 0, the function has a value of 0. The y-coordinate is 0. Minus f of 0. F has a value of 3. The y-coordinate is 3 at 0, so I get negative 3. And then I got f times g of negative 1. So that'll be f of negative 1 times g of negative 1. Wrote it backwards, sorry. What's g of negative 1? Negative 1. What's f of negative 1? 2. So I get negative 2. I'm sorry, I wrote it backwards, you guys, there. So I had started with f for the other ones. I apologize. I didn't want to confuse you. But so, again, g of negative 1 was negative 1, and f of negative 1 was positive 2. So that's why I multiply together. No, I'm not graphing them yet. It doesn't ask to graph, but I'll show you how you would graph. And then you would have this next one, which is f divided by g of 0, which is f of 0 divided by g of 0. What's f of 0? 3. What's g of 0? What's 3 divided by 0? Undefined. Can't divide by 0. So that's a problem. You can't do that. So if you wanted to add these, let's just suppose that you had an assignment that said add them. You know, let's actually graph it when we add them. All you do is you add the y values. So look, I'm down here at negative 4, and I'm up here at positive 3. What's negative 4 plus positive 3? Negative 1. What's negative 4 plus positive 2? I'm saying, let's say I was supposed to graph f plus g. Let's say that I was supposed to graph that. And I add the y value. So negative 4 plus positive 2 is negative 2. Estimate it. Negative 4 plus positive 1, negative 3. Negative 4 plus 0. So you can see I'm just adding them and moving along from there. So that's about it. I guess here you could do, we would actually have -2 plus +1 would be -1. So this would actually be you'd have an open circle and it would start to go up here, yada, yada. But that's the idea. You just add the y values. So you just add the y values, see what you get. Okay, let's try something that's, a little bit different. F of g of 1. So this is f of g of 1. Now this is a little bit tricky sometimes when people see what's going on here, but what is g of 1? So if you go over to 1, g has a value of -2. So what I really need to evaluate is f of -2. So now I go to -2, and I see what is the function f evaluated at -2? +1. Yep. See if you can do the second one. See if you can do g of f of -2. No, it's one solution. What we do is we got out -2, so we plugged it back into f, and we found where f was at -2. And that was my final result. See if you can try g of f of -2. Whoop. Sorry. So if you notice, if you try it the other way, if we plug in g of f of -2, you would do f of -2 first, which is 1, and then you would find 1 and evaluate g, which has a value of -2. Any questions on that? Okay, one last piece before we get to your assignment, and that's in regard to the domain of the functions. The domain of adding, subtracting, multiplying, and dividing is simply the intersection or the union of the two sets. The domain of a composition function is as follows. You guys are going to want to write that down. I was looking for a really good definition. I didn't find one, so I made up my own, and I like it better than the ones I read. So the domain of a composition function, f of g, is the domain of g that produce range that are in the domain of f. The domain of a composition function, f of g, is the domain of g that produce range that are in the domain of f. Now, I'll show you what it means there. And I don't have a, well, yeah, I'll adjust from last time. I didn't have a really good example last time, so I'll come up with a good example this time for you. Okay, you got it? 5, 4, 3, 2, 1, 0. Tyler, is there going to be an NBA basketball season? They are a bunch of idiots. The lowest salary in the NBA is like $2 million. Lowest salary in the NBA is like $2 million. It's higher than any other sport. And the players want more money. And I think that 3/4 of the teams last year actually lost money, and the players want more. Oh my gosh, yeah, it's tough. How are you gonna do it on $1 million a year? It's ridiculous. Go get a job in the off season, bake groceries, for crying out loud. That's what you guys would do. We live in a world that feels entitled to everything. It's so horrible. Everybody feels entitled. Okay, so given f of x is 2 over x, and g of x is 3 minus x, we want to find f of g, and we want to find the domain of it as well. Who could give me an expression that tells me what f of g is? Right, so you did 2 over 3 minus x. You plug that 3 minus x in there, okay? When I evaluate the domain, I need to think really critically about what's happening here, okay? And I'm going to use the definition. The definition says the domain of G. What is the domain of G? What numbers can you plug into 3 minus x? You can plug in, so let's just focus on G right now. You can plug everything into there, can't you? Absolutely anything into 3 minus x. You're going to get a result. So domain of G is all real numbers. And when you plug it in, you're going to get a range, okay? What is the range of G? What kind of numbers can you get out of 3 minus x? All real numbers. So again, if you look at the definition, it says the domain of G that produce a range that are in the domain of F. So what I need to check is these range values right here, these range values, which are all real numbers. Which of these range values can I plug in there? What can I not get for this? 0. X cannot be 0, right? So the range values are produced by 3 minus x. And we're saying that cannot equal 0. So what is, if you say 3 minus x can't be 0, then x can't be, right, so x cannot be 3. Now you're saying to yourself, well, Mr. Gens, I was able to look at the original function, just automatically identify that that was obvious. I couldn't plug 3 in the denominator. It's not, most of the time it works out like that, but not all the time. Let me show you one more example. Cross these out. Get rid of them. Yep, that's the domain. The domain. The domain for the composition function is x cannot be 3. So if you want to write it like this, say domain could be negative infinity to 3, and then 3 to positive infinity. You could write something like that. That'd be fine. No, you'll see the example here. Let's say we had square root of x and x squared. Okay, you're going to see how this makes things slightly more difficult. Okay, if you were to compose g of f in this situation, f is the square root of x and g of x is x squared. What would you do to compose g of f? Right. You'd take that square root thing and you'd plug it into there, right? So you get g of f of x is actually equal to the square root of x quantity squared. What's the square root of x squared? X. Now think about it. Is there anything that you can't plug into x? No. But yet our domain is not all real numbers. It's not. Watch. We start with f because that's what we're plugging in first. What's the domain of f? All positives. Yeah, the domain, you can't put in negative numbers in there, so the domain of f is x is greater than or equal to 0. And then I have to see what I'm going to get out. If I plug in just positive numbers into square root functions, what am I going to get out? Positive numbers. So the range is y is greater than or equal to 0. So those are my outputs. So I'm only getting out positive things, okay? Now, let's check. Can you plug just positive things into x squared? Is that okay? Yes, it's okay to do that. So my domain remains x greater than or equal to 0. Those are numbers I can plug in. But I have to check to see if my range values I get out of that are available to plug into the new one. So notice that we came up with x for our function in terms of our composition. But if we look at that, we would say, well, all real numbers is our domain. No. Nope. Domain's x greater than or equal to 0 because of where we started from. Is that kind of tied together a little bit? Yeah, it's got to work all the way through. Yep. Okay.